Hello, welcome to lesson 4, energy, temperature, and phase changes. Our intention here is to learn how energy, temperature, and phase changes are related. Okay, so we're talking about the phases of matter and energy. So what is the actual cause of a phase change? Why does ice melt into water, like at the chemical level, the nanoscopic level? What is temperature? Like, what does that really mean now that we're actually looking at it in the realm of science? And what is a heating curve graph? Because understanding these graphs is a big part of understanding phase change. So let's take a look at this, the cause. Why does ice melt? So an increase in energy causes the phase change from solid ice to liquid water. But what is happening at the molecular level when we look at the molecules? Okay? So the cause of phase change. Solids have a definite shape and volume, and there are strong bonds between those molecules. They're holding on tight, like we see here, this guy trying to save his friend, holding on real tight. Okay, so you got a little joke here. So first frozen molecule, right, hanging here. Second one, I got you. And then we have thermal energy there. Oh, no, you don't. Hopefully you've seen a little bit of Always Sunny to get that joke. But as energy is added, the bonds start to weaken. And when they start to break, the phase begins its transition. That's when we start changing, when those bonds are breaking. And now the energy is typically called thermal energy, and we describe it as temperature, like, oh, it's 30 degrees, it's 40 degrees, it's 80 degrees in Fahrenheit. In Celsius, it could be a smaller number typically, unless you're heating something up a lot. So let's talk about temperature. Okay, so temperature is a measure of thermal energy, and that energy is actually the average of the kinetic energy of the molecules themselves. If you see our little GIF here, you see that this really cold molecule close to 0 Celsius here is barely jiggling. Then the 20 Celsius version is jiggling a lot. And then the 40 Celsius is jiggling really hard. And so this can really help you see that those bonds, they weaken because of all the forces pulling on them and pushing on them as they jiggle. These molecules, they vibrate in place unless they're a gas, in which case they can't actually move around. Okay? Now, this energy can be modeled with a formula. And if you take physics next year, you're going to see this formula and use it a lot more. But it's kinetic energy equals half of the mass, how much it weighs, times the velocity, how fast it's moving, squared. Now, kinetic molecular theory states that all molecules vibrate or move. Everything, all these molecules are constantly, in a tiny, tiny, tiny way, vibrating or moving around. And that movement is different when it's a solid or a liquid or a gas. Okay? So if we add enough energy, these bonds actually will break. That temperature is called the melting point. The chemical starts to melt until it becomes a liquid as these bonds are breaking. Now at the boiling point, the chemical begins to boil and individual molecules break all the bonds and they become gases. They just float off as a gas now. Okay? Now the heating curve graph, we can see one here. Every chemical has a graph like this. Any chemical can have a heating curve graph set up this way. But the temperature at which it reaches these points is unique to each chemical. And you may notice on this graph that we have temperature on the y-axis and we have time on the x-axis. And this graph is measuring if you are adding a continuous or the same amount of heat to it constantly. So like if you set your stove to medium, right, or to 4 out of the 7 numbers on your stove, you leave it at 4 the entire time. You don't move it up and down, and then you get a graph like this. Now, while a chemical is melting, all of the energy that's being added is breaking the bonds. So the temperature actually stays the same. You see these plateaus, these flat lines, right, these horizontal lines. These plateaus are where you have a phase change. So it gets warmer and warmer and warmer, and then as soon as it gets just warm enough for bonds to break, the energy is used just to break bonds. And so you'll have your ice melt this entire time. So, like speaking about ice water, it is going to stay 0 Celsius, the melting point, until all the ice melts. So if you have a glass of water with ice in it, The water in that glass is about 0.51 Celsius because all the energy is being used to melt more ice, so the water stays cold. And that's it. That's our whole lesson. Good luck with the work that's involved, and have a great rest of your day.